For centuries, we believed we had a solid understanding of the universe's expansion. When Edwin Hubble first observed that galaxies were moving away from us in all directions in the 1920s, it confirmed a key tenet of the Big Bang theory. Hubble's law told us that the universe is expanding, and it provided a method to measure the rate at which it's happening. This discovery was a cornerstone in our understanding of the cosmos. We assumed that this expansion was a steady process, with galaxies slowly moving farther apart due to the initial energy released in the Big Bang. But something strange happened in the late 1990s that shattered this long-standing assumption. In an unexpected twist, astronomers discovered that not only was the universe expanding, but it was accelerating. The rate of expansion was increasing over time, not slowing down as we had assumed. This revelation turned our view of the universe upside down. It opened the door to one of the most profound mysteries in modern cosmology, the existence of dark energy. The idea that the universe is accelerating in its expansion defies what we thought we knew about gravity and the forces shaping the cosmos. Gravity, as we understand it, is an attractive force, one that should be slowing the expansion of the universe. But here we were, observing a universe that was expanding faster and faster. This wasn't just a minor deviation from the expected, it was a fundamental change to the very way the universe behaves. The discovery of this accelerating expansion prompted scientists to propose a new, invisible force driving the expansion, a force we've come to call dark energy. This mysterious energy accounts for a staggering 70% of the universe, yet we know almost nothing about it. It is both the most dominant and least understood force in the cosmos. The question is, what is dark energy, and why is it accelerating the expansion of the universe? To answer this, we need to dig deeper into this cosmic puzzle and explore the evidence and theories surrounding dark energy. When we speak about dark energy, we're referring to a force or substance that is invisible, undetectable by conventional means, and yet exerts an undeniable influence on the universe. It's the mysterious missing 70% of the universe, and it's responsible for the accelerating expansion we've observed. But what exactly is dark energy? The answer isn't simple, and in fact there are competing theories. First, it's important to clarify that dark energy is not the same thing as dark matter. While dark matter is another invisible substance that makes up about 25% of the universe and exerts gravitational influence, dark energy has a very different role. Dark matter pulls things together through gravity, whereas dark energy pushes things apart, accelerating the universe's expansion. Dark matter and dark energy are often confused, but they are two fundamentally different forces. Currently, there are two leading theories to explain what dark energy might be. The first is the cosmological constant, a concept introduced by Albert Einstein in 1917 as part of his theory of general relativity. At the time, Einstein introduced this term to balance out his equations for a static universe. Later, he abandoned it when it was discovered that the universe was expanding. However, with the discovery of dark energy, the cosmological constant was resurrected. It proposes that dark energy is a constant force, uniform throughout space, that is responsible for the accelerated expansion of the universe. Essentially, the cosmological constant acts like a form of energy that permeates all of space, pushing galaxies apart at an increasing rate. The second theory is called quintessence. Unlike the cosmological constant, quintessence proposes that dark energy is not a constant, but something that changes over time and space. This theory suggests that dark energy might vary in strength depending on the specific region of the universe, or that it might evolve in intensity as the universe ages. The difference between these two theories has profound implications for our understanding of the universe's fate. If dark energy is a cosmological constant, it means that the expansion of the universe will continue to accelerate indefinitely. However, if it's quintessence, the future behavior of dark energy could change, leading to different outcomes. While we have yet to conclusively determine which theory is correct, both open up a vast array of possibilities about the fundamental nature of the universe and the forces that govern its evolution. The evidence for dark energy is compelling, though it remains one of the greatest mysteries in science. One of the key pieces of evidence comes from Type Ia supernovae. These stellar explosions are known as standard candles because they emit a consistent amount of light, allowing scientists to measure their distance from Earth with great precision. In the late 1990s, two independent teams of astronomers, using these supernovae, discovered that galaxies were moving away from us much faster than expected. The brightness of the supernovae was fainter than it should have been, suggesting that they were farther away than anticipated, and thus the universe's expansion was accelerating. This finding provided the first major evidence that something beyond just gravity was causing the expansion to speed up. It was the beginning of our current understanding of dark energy. In addition to the supernovae, the cosmic microwave background, CMB, radiation plays a critical role in confirming the existence of dark energy. The CMB is the afterglow of the Big Bang, and it provides a snapshot of the universe as it was just 380,000 years after the event. By studying the tiny fluctuations in the temperature of the CMB, scientists can map out the structure of the early universe and measure its rate of expansion. These measurements have shown that the universe's expansion has not only been accelerating in recent times, but that dark energy must have been a dominant force in the universe's evolution for much of its history. The CMB's patterns support the idea that dark energy is responsible for the current expansion of the universe and provide further evidence for the existence of this mysterious force. Large-scale surveys, such as those conducted by DESI, Dark Energy Spectroscopic Instrument, and Euclid, are also playing a crucial role in mapping the universe's expansion. These surveys aim to measure the distribution of galaxies and map their movements across the cosmos.